Hello, this is your special education virtual content specialist here with the 8th grade lesson for April 12th. This lesson, as with all lessons, can be found in TeachHub. For teachers, we provide the unit, the day, the title of the lesson, the focus question, the learning objective, standards, and objectives. Additionally, we provide guidance for using this resource, including instructional and technology guidance, implementation guidance for this lesson, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging with students with disabilities and engaging multilingual learners. 8th graders are working on Unit 7, Exponents and Scientific Notation, Day 22, representing small numbers on the number line Part B. How can we use multiples of 10 to express decimal numbers? For the introduction, students are asked to complete the table, in which the columns are labeled as decimal, expanded, and multiple of a power of 10. The first row of 3/10 is already completed for students. So moving on to the second row of 7/10, an expanded form that's 7 times 1/10, and as a multiple of a power of 10, 7 times 10 to the negative first power. The third row would be 3/100, which is 3 times 1/10 times 1/10, which is 3 times 10 to the negative second power. And the last row is going to be represented by this decimal, which is the same thing as 5 times 1/10 times 1/10 times 1/10 times 1/10. To further support students, you can also provide them the sample sentence starter. I noticed that the values in the table are blank. To answer the question, what do you notice about the values in this table? So students can focus more on the content rather than the sentence structure. For the Explore, you can separate each of the slides as an I do, we do, you do. So for the I do, the question states, or the situation rather, states the radius of an electron is about this decimal in centimeters. So they ask you to write the number as a multiple of a power of 10. And this is represented by 3 times 10 to the negative 13th power. And on the number line, label each tick mark as a multiple of a power of 10. Each tick mark is going to be labeled in multiples of 10 to the negative 13th power. So we have 1 times 10 to the negative 13th, 2 times 10 to the negative 13th, 3 times 10 to the negative 13th, 4 times 10 to the negative 13th, 5 times 10 to the negative 13th, 6 times 10 to the negative 13th, 7 times 10 to the negative 13th, 8 times 10 to the negative 13th, and 9 times 10 to the negative 13th. This is a perfect opportunity to remind students that even though the absolute value of negative 13 is greater than the absolute value of negative 12, when it comes to working with scientific notation or numbers represented in this form, the negative value actually represents that it's a much smaller value. And that's why these multiples of 10 to the negative 13th power are leading up to 10 to the negative 12th power. Now we're going to plot the radius of the electron in centimeters on the number line, and 3 times 10 to the negative 13th power is right here. For the we do, we're presented with the mass of a proton, which can be expressed as 1.7 times 10 to the negative 24th power. So on the number line now, together we're going to decide what power of 10 to put on the right side of this number line. And students should realize that it should be 10 to the negative 23rd power, because 1.7 times 10 to the negative 24th is greater than 10 to the negative 24th power, but less than 10 to the negative 23rd. And now we're going to label each tick mark. So 1 times 10 to the negative 24th, 2 times 10 to the negative 24th, 3 times 10 to the negative 24th, 4 times 10 to the negative 24th, 5 times 10 to the negative 24th, 6 times 10 to the negative 24th, 7 times 10 to the negative 24th, 8 times 10 to the negative 24th, and 9 times 10 to the negative 24th. And now we're going to plot the radius of the electron in centimeters on the number line. 1.7 falls between 1 times 10 to the negative 24th power and 2 times 10 to the negative 24th power. So it's going to be approximately right there. For the U-do, students are given that point A on the zoomed in number line describes the wavelength of a certain X-ray in meters. To help students who might have visual issues processing this, I've only included the zoomed in portion, so they only have to focus on that number line rather than the number line of the wavelengths of other types of light. So here we have point A, and the wavelength of this X-ray can be written as 6.1 times 10 to the negative 12th power meters, and the wavelength as a decimal will look like this. So for this question, students might want to write 61 times 10 to the negative 12th power or something similar, and you want to remind students that 61 does not fit on the number line because there aren't 61 tick marks between the two ends of that number line. And ask students how many tick marks are on the number line and what reasonably would be at point A. For the summary, you're going to have students answer how can we use multiples of powers of 10 to express decimal numbers, and you can use a sentence starter to support them. You can also have students complete the cool down. So some of the additional practice you may have students do include Khan Academy, approximating with powers of 10, the Open Up Resources practice problems, or the Engage New York Grade 8 Module 1 Lesson 7 problem set. As always, here are the resource citations for all the technology and sources that are used in the lessons and that you can further look into if you would like to support your lessons. If you have any questions, please contact your virtual content specialist. Thank you.